I'm Alexandre. I'm currently pursuing a PhD in computing at IST in the University of Lisbon, and I'm affiliated with INESC-ID, which is a research institute. So my first interaction with FAG was in my cryptography master's class. Our final project was an FAG calculator. If I recall, I think we used Microsoft Seal. And frankly, I thought, man, the project wasn't too interesting. So it was just a simple calculator. I thought, this is kind of not that interesting. But then we learned about the previous year's project, and the professor was a bit more inspired then. And so that one was a program for tallying votes from electronic voting machines. It was, still a simulation, so to speak, a toy problem. But I thought that one was, a lot more interesting and showcased FAG a lot better. And that one I thought was actually, super interesting. So I'm still a bit of a novice in the FAG space, but I had the privilege of attending chess this year, and even though I haven't worked with it yet, I learned about TFAG, and I thought that was super interesting. I had no idea you could do things like assembling Boolean circuits fully homomorphically, and I thought that was super neat, and I look forward to having any opportunities to work on something of that sort. So I started work in FAG as part of an invitation by my colleagues. They had this in-progress work, which is what we're going to be presenting. And even though my background isn't in cryptography or anything, there were some skills which I do have, which are more to do with the computing and the performance analysis and simulation that they needed. And so I got to learn about a new topic, and that was super interesting. So the biggest challenge here with this work was definitely how complex the algorithms are and all of the theory. I kind of tried brute forcing my way at first, just running the code and just trying to interpret it at a bit of a higher level. But that didn't really work out. So I had to really go in and dive deep into the theory, into how the algorithm works. And it was tricky. So it's complex, but it was also very rewarding, and it made everything a lot easier. Right. So this is probably the one I'm least qualified for answering, since I'm a bit of a novice in this space. But from my point of view, I would say for a wider adoption, we really need to push towards higher performance in order for a lot more workloads to be realistic and to be done in an FAG context. Yeah, that ties well into my previous answer, which is performance. I think performance is definitely the biggest priority. I remember from my first project in the cryptography class I mentioned. So one of the first tests was just adding up 2 or 3 numbers. So you type in 3 plus 2 plus 3, and it encrypts them, it sends them to the server, and so on. And you're sitting there waiting, and you're thinking, I'm just adding 3 numbers. Why is this so slow? Of course, the FAG has evolved since then, and everything is quite significantly faster. But still, I think performance is the most important improvement. Yeah, I would say don't do what I did, which was try and sort of brute force my way as an outsider, and really try to, if you're just getting into it, try to really learn the theory, try to understand the algorithms, try to understand why things are done the way they are. And I think that's going to make everything a lot easier for you.